Welcome to EDU World Space.
The volume of the water in the channel is defined as V is equal to A times delta L. Now, the volume flow rate is then we can write as Q is equal to V upon delta T is equal to A times delta L upon delta T. But we know the delta L upon delta T, this term is nothing but equivalent to V. So I can write Q is equal to A times V. Okay. The area here is the cross sectional area normal to the flow direction. So, in that case, I can define my area A is equal to B into D. Therefore, my Q value will be instead of A, I can write B into D into V. Okay. Moving further, applying the continuity of the flow, as we know, Q1 is equal to Q2 is equal to Q. So in that case, I can write my V1 is equal to Q upon BD1 and V2 is equal to Q upon BD2. The resultant pressure force is written as P is equal to rho g T. The standard equation is rho gh. Here we are concerning height as a symbol d. That's why we have written rho g d. So therefore, rho into g is equal to gamma, or you can say that P upon d. Okay. Now, therefore, my P1 will be gamma d1 and P2 will be gamma d2. Similarly, I can write about the force. The force F is equal to P times A, and my area A is 1 half BD. Therefore, specifically I can write force F1 is equal to 1 half times P1 BD1 is equal to 1 half gamma B D1 square, and F2 is equal to 1 half P2 B D2 is equal to 1 half gamma B D2 square. Okay, now moving towards the third part. Here we are applying the impulse momentum principle. So I can write the equation accordingly. Delta m v1 plus f1 delta t minus f2 delta t is equal to delta mv2. Okay, by simplifying further and rearranging all the terms, I will get the final equation F2 minus F1 is equal to delta M upon delta T times V1 minus V2. But we know the V1 value and the V2 value. V1 is equal to Q upon BD1 and V2 is equal to Q upon BD2, and delta M upon delta T value is rho into Q. So I can put everything here and rewrite this formula as 1 half gamma B D2 square minus 1 half gamma B D1 square, which is my F1, is equal to rho Q, that is my del M upon del T, and instead of V1 I can write Q upon BD1 minus Q upon BD2. Okay, by simplifying this equation I will get the final one as 1 half gamma B. I'm taking this B common, D2 plus D1 into D2 minus D1 is equal to rho Q square times D2 minus D1 upon B D1 D2. Now, utilizing the equation that gamma is equal to rho G, I can rewrite this formula in terms of Q square. I will get my final answer. Q will be B times square root of G D1 D2 D2 plus D1 upon 2. So this is my final Q equation.